This is part 2 for additional topics. This is starting on page 5. So for this video, we're going to do a short section on mass and weight, and then we're going to get into trigonometry, which is the meat of this section. And this trig part has a little bit of geometry in it also. Okay, so we're going to do just a little bit on mass and weight. This is just one page. Definition: weight is the measure of the gravitational pull on an object. It says your weight varies depending on the force of gravity. For example, if someone weighs 200 pounds on Earth, he or she only weighs 128 pounds 1,000 miles above the surface of the Earth. Okay, so that means as you travel above the surface of the Earth, gravity changes and you actually weigh less. Okay, next definition we have mass. Mass is a measure of the quantity of matter in an object determined by its molecular structure. Your mass is exactly the same in all locations. Okay, so this is more of a scientific term. So your mass will not change, okay, because it is the molecular structure. Okay, so it's a measure of the quantity of matter. Now, weight is a measure of gravitational pull, so weight does change. Okay, so the English system has a couple units of weight. These need to be memorized. Okay, 16 ounces is 1 pound. We denote pound as lb. And then 2,000 pounds is 1 ton, which is a capital T. Okay, again, make sure you have these memorized. This is units of weight for the English system. When we convert between them, we'll just use dimensional analysis like normal. Okay, and then units of mass, this is for the metric system. The basic unit of weight is the gram, used for very small objects such as a coin or teaspoon of salt. For example, a nickel is about 5 grams. Okay, so you can kind of get a sense of how much a gram would feel, or how heavy a gram would feel. So a nickel is about 5 grams. Once again, we have the King Henry died Monday drinking chocolate milk, with the G replacing the M in the middle. Okay, so instead of having this M, we're going to have a G here for grams. So we have kilograms, hectograms, decagrams, grams, decigrams, centigrams, and milligrams. Okay, number 1, convert 8.7, that's decigrams, to milligrams. Okay, so we have King Henry died Monday drinking chocolate milk. I always kind of add in these D's. So this is decagram, this is decigram. This M changes to a G for gram. This is DG, that's actually this one. And then deca is DA. So this would be, decagram would have DAG here. Okay, so we're going from decigram to milligram. So to the right, 2 places. So we have 8.7, and then to the right, 2 places. So this would be 870 milligrams. Okay, and then the next one converts 950 milligrams to grams. So again, King Henry died Monday drinking chocolate milk. We have deca, we have deci. This is grams. So we want milligrams to grams. So to the left, 1, 2, 3 places. So we have 950 here, decimal point is here. To the left, 1, 2, 3 places. So this is 0.950 grams. Okay, so really this is just a review. If we were converting in the English system, we would use dimensional analysis. Okay, so that ends mass and weight, so there's a pretty short section there. Now we're going to start trigonometry, and we're actually going to start with some definitions that are more of geometry definitions, but we need these definitions to move on with trig. Okay, so first definition, we have a ray. It's a directed line segment. Okay, so a line segment looks like this. Okay, and then a ray means it's directed. Okay, so you have a direction here. An angle is the union of 2 rays having a common endpoint, where the endpoint is called the vertex. Okay, so we've seen an angle before. Okay, but in geometry, this is the definition. It's just an intersection of 2 rays, okay, where we have an endpoint is common, and then this is called a vertex. Okay, so you guys have seen this before. Number 3, the measure of an angle is the amount of opening the angle has from the endpoint. Okay, so we measure this. So what is this amount of opening? 1 degree is 1/360th of a circular that should be rotation. So a complete circular, I spelled that wrong both times, circular rotation contains 360 degrees. We use the symbol, we have this open circle, 4 degrees, which you guys have probably seen this before too. Okay, so this means a complete circle, okay, which is technically isn't an angle, it's a circle, would be 360 degrees. Okay, so 1 degree is 1/360th, so I can't really draw that. Okay, but for example, which the circle would mean, okay, I have one ray here, and then the other ray would be all the way around. Okay, let's just do an example. Specific degree would be this angle. Okay, it's a right angle, or this is the angle you have in squares and rectangles. This is 90 degrees. Okay, so you can see it's a quarter of a circle. Okay, so a quarter of 360 is 90. Okay, another really common angle is a straight angle. Okay, here would be the endpoints for the rays. So you have 2 rays coming together here to form a straight line. So what would this angle be? This is 180 degrees. Looking back at your circular rotation, okay, that's half of 360. Okay, something like this, which I didn't measure it, so it's not exact, might be 45 degrees. Okay, number 4, I'm going to just move on with some definitions. It says vertical angles created by intersecting lines are a pair of angles whose sides are 2 pairs of opposite rays. Vertical angles are congruent. Congruent means equal. Okay, so let's break this down. It says vertical angles created by intersecting lines are a pair of angles whose sides are 2 pairs of opposite rays. Okay, so if you were just drawing 2 lines here, and they have to intersect. Okay, it says vertical angles are the pair of angles whose sides are 2 pairs of opposite rays. Okay, so for example, this angle and this angle are vertical angles. Okay, they're congruent. That means their measures are the same, which we normally denote that with this line here. Okay, so I don't know what these measures are, but I know that they're the same. Also, we have these 2 angles are the same. Okay, because they're vertical angles. Okay, another definition, number 5, supplementary angles are 2 angles, the sum of whose measure is 180. Okay, so I'm just going to start with a angle that is 180, and then I could maybe put in a line here to make 2 angles. Okay, so that would be supplementary angles because the whole thing is 180. So these 2, which I'm going to put another line here since it's different. So those 2 angles would be supplementary. And number 6, complementary angles are 2 angles, the sum of whose measure is 90. Okay, so again, I'm going to start with a 90-degree angle, and I'm just going to split it somewhere. So we have this angle and this angle. So those would be complementary angles. Okay, top of page 7. It says any line that intersects a pair of lines in a plane, is a transversal of those lines. Okay, so if you have just 2 lines here, okay, I just randomly draw 2 lines. So you have 2 lines in a plane, and then you take a line and you intersect both of those lines. Okay, this line here is called a transversal. Okay, transversals are very important when the original 2 lines are parallel. Okay, so this would be a transversal. Okay, and transversals are again very important when you have parallel lines. So I'm going to go ahead and write that down. So we have, I'll just name this line M, this line L. I'm going to say M is parallel to L. Okay, parallel, which you should have seen this definition before, just means that they never intersect. Okay, so now we have something important here. It says if any 2 distinct coplanar lines, that just coplanar just means that they're in the same plane, are cut by a transversal, then a pair of corresponding angles, alternate interior angles, or alternate exterior angles are congruent if and only if the lines are parallel. Okay, so we need to go over what all of these words mean. So corresponding angles, alternate interior, alternate exterior. Okay, so let's go ahead and start with two parallel lines. It says we have a parallel here. Okay, and then we're going to go ahead and draw in a transversal. Okay, corresponding angles. Okay, so the first one for corresponding would be this angle and this angle. Okay, that would be a pair of corresponding angles. Okay, that means that they're congruent. I could have also picked this angle and this angle, which I'm not going to draw in because it's just going to get messy, so I'm going to write corresponding here. Okay, you could do this angle and this angle. Okay, and you could do this angle and this angle. So one needs to be outside of the parallel lines, one is inside and on the same side. Okay, next I'm going to do alternate interior. So again, I'm going to do two different parallel lines and a transversal, which I need to make these look parallel. Okay, alternate interior. So that means alternate, which is opposite, and they need to be interior, which means they're going to be inside of the parallel lines. So alternate interior would be like this angle and this angle. Okay, I could have used this angle and this angle. So those are also congruent as long as these lines are parallel, which I've drawn them to be. Okay, and then the last one, alternate exterior. So again, let's do parallel lines and a transversal. Okay, alternate is opposite, and then exterior is going to be outside of the parallel lines. So this angle and this angle. So opposite of the transversal, this side, okay, which I need to put all of that in. Okay, and then outside, so exterior. I could have said this angle and this angle. So this one is alternate exterior. Okay, so corresponding, same side of the transversal and same side, one interior, one exterior. I'm sorry, exterior and interior. Alternate interior, they have to be inside the parallel lines and opposite sides of transversal. Alternate exterior, they need to be on outside of the parallel lines and then opposite of the transversal. The sum of the measure of the angles of a triangle is 180 degrees. That has to be memorized. Okay, which you guys probably already know this. That's a huge theorem in geometry, is that the angles of a triangle add up to 180. Okay, so it says use the above rules. That's meaning this rule, and then we're going to do this rule too, to solve the angle puzzle. So let's first start with two parallel lines and a transversal. Okay, and I'm going to say that this angle here is 39 degrees. Okay. All right, so I want to know all the other angles in this picture. Okay, so first of all, we have corresponding angles. So a corresponding angle for this 39 degrees would be here, which I'm going to go ahead and label so you can look back on your notes and you can see the work here. Okay, so I'm going to put a line here. Okay, so angle 1, we're going to have degrees for all of these. We had 7. Okay, so corresponding angles, we have 4 here. Okay, so angle 4 would be 39 degrees, and because we have corresponding. The only reason I chose that is because I'm going in order, so I'm looking at all the corresponding angles. Okay, so we know this is 39. Let's just look at alternate interior. We have that this one is 39, so an alternate interior to 4 would be 2. Okay, so that one's 39. And here we have alternate interior. Also notice that 39 and 2 are vertical angles, which we had on the previous page. Okay, they're opposite, so it should be 39 also. So this alternate interior isn't the only reason we have 39 degrees. Let's look at alternate exterior. So for 39, we need opposite and outside, so that would be 6. Okay, so angle 6 is also 39 degrees. I'm going to do alternate exterior here. Okay, but again, angle 4 is 39 Okay, so, and they're vertical angles, so they have to be the same. Okay, so how are we going to figure out? We need 1, 3, 5, and 7. Okay, well, probably the thing I'm noticing is this whole angle here is 180 degrees. Okay, we have 39 here, so we need to figure out what this 1 is. We would just subtract from 180, which I need to use a calculator for. I just want to make sure I get it correct. I got 141. And I'm going to put that with supplementary angles. Okay, by vertical angles, we have the angle 3 is 141. Okay. By alternate interior, we have that angle 5 is 141. And then by, again, vertical angles is probably the easiest to see, angle 7. Okay, again, you can have different for these, different reasons for those. Okay, those are just the ones I saw first. Okay, and we also want to use an example for the sum of the measure of a triangle. So let's say we have a triangle that looks like this, and I have a right angle here. I'm going to say this is 25 degrees. Okay, so this angle, just call it 1. Angle 1 would be, okay, this angle plus this angle plus this angle has to add up to 180 since this is a triangle. So we would do 180 minus 25 minus a right angle is 90 degrees. Okay, so 180 minus 25 minus 90, I got 65 degrees. Okay, bottom of page 7, we have another definition. It says an angle is in standard position if its vertex is located at the origin on an XY coordinate plane. So let's go ahead and draw that out. Okay, so it's in standard position if its vertex is located here. So for example, this angle, okay, would be in standard position because the vertex is on the origin. If the angle is measured in a counterclockwise direction, the angle is said to be positive. Okay, so if I measure like this, it's going to be positive. This would be an acute angle. You can see that it is less than 90. Okay, so this would be positive. If the angle is measured in a clockwise direction, so moving this way, the angle is said to be negative. So if I were to measure this one, it would be a negative angle. Okay, which you can see would be a large angle. It's more than 180. Okay, more than whatever 180 plus 90 is, which is 270. Okay, so that angle would be a negative degrees. Okay, on to page 8. It says special types of angles whose sides lie on an axis or quadrantal angle are 0, 90 degrees, 180, 270, and 360. Okay, so we will just draw that out. So these are special angles in standard position. Okay, this angle here is 90 degrees. Okay, this angle here, so here to here is 180. This angle here, so measuring all the way around, is 270. And then this angle here, measuring all the way around, is 360. Okay, and those are positives. An angle, let's say negative 90, would look like this. So this would be negative 90 degrees if I am traveling this way, measuring this way. So all of these in standard position, I was measuring in the positive direction. Okay, example, it says sketch an angle of 30 degrees in standard position and 135 degrees in standard position. Okay, we're just sketching here, so we just kind of need to make an educated guess on where it should land. Okay, so we have 30 degrees, we have our vertex here in standard position. Okay, and this is positive. This is 90, so it needs to be less than 90. Half of 90 would be here, that's 45, so it actually needs to be less than half. So about here would be 30 degrees. Okay, and then negative 135. Okay, so since we're negative, we're going to be moving this way. And I need to make that straighter. Okay, so this would be 90. We need it more than 90. This would be 180, so we need it somewhere in between here. Okay, so I'm going to just put it about here. This would be negative 135, and I measured this way. Okay, I should have put an arrow in here. I'm measuring this way for that angle. Okay, next definition, we're going to start looking at some circles. Okay, some formulas that go with circles. And then after we get through circles, we'll really start on trig. Okay, so it says definition, an arc is a portion of a circle created when one draws a circle, but stops somewhere before the circle is completed. Okay, so if you have a circle here, okay, an arc would be something like this. Okay, so you're drawing along the circle, but you're not actually completing the circle. So that would be an arc. Okay, just this piece here. So the length of the arc around an entire circle is called the circumference. Circumference is 2 pi r. Okay, so if you're trying to find the perimeter of a circle, you use 2 pi r. This has to be memorized. You guys should already know this. I'm sure you've seen it a lot in school so far. So circumference is 2 times pi times r. Next definition, an arc length S is the length of the curve around the arc. Okay, so now we have the length of a full circle. An arc length is, we want the length of an arc here. Okay, if a circle has radius r and arc has angle theta, then the arc length S is 2 pi r times theta over 360. Okay, so what this means is we're going to start with a circle. Okay, it has radius r. Okay, so I'll just go ahead and write that. We have radius r here. Okay, and we want to find an arc length here. Okay, alright, so the whole thing, the whole circle here is 2 pi r. Okay, but we just want this portion. Well, this portion has the ratio of theta over 360 because this whole angle in here is 360. Okay, but we want just this portion. So we would do theta over 360 times the whole thing. Okay, so once you have the whole length, you multiply by theta over 360. That's going to just give you the arc length is what you want. Okay, so example, it says find the arc length along a circle of radius 10 units subtended by an angle of 215. Okay, so let's draw a circle. Okay, we have a radius of 10. We don't know what the unit is. It just says units. Okay, and the angle is 215. Okay, so 215 from this angle here, it needs to be, 215 is greater than 180, so this would be 180. So I'm just trying to make this picture more accurate. Would look something like this. Okay, so this angle here would be 215 degrees. Okay, and we want the arc length that is created by that. So I'm going to just color this bold so you guys can see. So we want the length of this. Okay, again, the length of the whole circle would just be 2 pi r, in this case 20 times pi. Okay, but we just want this portion. So what is this length? Okay, so we're just going to follow here. The length is 2 times pi times r, which in this case is 10, times theta, which our angle is 215 over 360. Okay, so this is 20 pi times 215 over 360. Okay, notice if I wanted to do the whole thing, okay, if you want to do it as an angle, this would be 360 over 360, which would just change to 2 pi r or 20 pi. Okay, so again, that's the circumference. Alright, I'm just getting out my calculator for this, so I'm doing 20 times 215 over 360, which I got about 11.94 pi. So that would be that length. This length here. Okay, so we have done the length of an arc. Now we're going to do the area of a sector created by an arc. So it says the area of a sector, this is bottom of page 8, with radius r and angle theta is, we have area equals pi over 360 times pi r squared. Okay, the area of a full circle is pi r squared, which again, you should have that memorized. Okay, now the area of a sector. Okay, so a sector is created by an arc. Okay, so this would be this area here, created by an arc here. Okay, so again, the area of a whole circle is pi r squared. Okay, but we just want this portion of the circle. Okay, this portion here the ratio is whatever your angle theta is over 360 times the whole thing, which would be pi r squared. Okay, so page 9, top of page 9, we're going to do an example, an application of that. Okay, it says an automatic lawn sprinkler sprays a distance of 20 feet while rotating 30 degrees. What is the area of the sector of grass the sprinkler waters? Okay, so we have that. Let's just put our sprinkler here, and it sprays a distance of 20 feet. Okay, so we have a distance here. And then it says it rotates 30 degrees. Okay, so I should have drawn it the other way. Okay, so it rotates 30 degrees. Okay, so your sprinkler is moving this way. Okay, this is still going to be 20 feet. Okay, because the sprinkler hasn't changed its length, it just rotates. Okay, so we want this area here. Okay, which you can see is a sector. Okay, because, which we have here. Okay, you would draw on the circle that has a radius of 20 feet. Okay, so the area is pi r squared. That's the area of the whole circle. Okay, but we just want this portion, which that portion angle-wise would be theta over 360, which instead of theta, we have what it is 30 over 360. Actually, no, let me change this to theta and then I'll fill it in. Sorry. Okay, so this is pi r squared is 20 squared, and then theta here is 360, which I'm just going to plug all this into my calculator. So 20 squared times 30 over 360. And I got about 33.33, and then don't forget the pi. The unit we actually have is feet squared. Okay, so if you were to go ahead and multiply that by pi, you would get about 104.72 square feet. So that's what this sprinkler covers. Okay, next definition, we have 1 radian. Okay, so this is another way to measure angles. So far we've just looked at degrees. Now for radians, it says it's the measure of a central angle of the circle that intercepts an arc equal in length to a radius of that circle. Okay, so 2 pi radians is 360 degrees, or 1 rotation. Okay, so 2 pi, which again I'm just going to put it in standard form, is a 1 rotation, 1 complete rotation. Okay, so that is 2 pi radians. Okay, pi radians is just half a rotation. Okay, or it's the same as 180 degrees. So that would be pi. 1 radian is about 57.3 degrees, or a quarter of a rotation. Okay, which we're not going to look too much into that. We really don't look at specific radians. We look at pi radians, 2 pi radians, pi over 4 radians, pi over 3 radians. Okay, we really look at numbers with pi for radians. Okay, so really important. 1 full rotation is 2 pi, 1 half rotation is pi. Since a half of rotation is pi, that would mean half of a half, which would be here, would be half of pi, or pi over 2. Okay, so we're going to go ahead and stop there. The next section is going to be pretty long, so this is going to be identifying special angles. Okay, and this is really where the trig is going to start coming in. Okay, so we'll go ahead and stop there, and then we'll pick this up in the